Hi everyone, welcome to my Max Academy. In this video, we will continue with the section 4.5, which is nature of the roots from the chapter Quadratic Equation, chapter 4 of 10th standard CBSE Mathematics. We will continue with nature of the roots in page number 88 in your textbook. So page number 88, in your textbook, nature of the roots. Nature of roots. So what means is, see, we know the general form of quadratic equation. So what is general form of quadratic equation? So general form is quadratic equation is ax square plus bx plus c equal to 0 and a is not equal to 0. This is general form of quadratic equation. And when we talk about the nature of the roots, which we had discussed in the earlier videos also, right? Nature of the roots means we will find the value of the discriminant, and that is denoted by the letter D. Discriminant means D, and D is given by the formula b square minus 4ac. b square minus 4ac. So depending on the value of the discriminant, we can tell how the roots of this quadratic equation will be, right? The condition is, it is also given in your page number 89 in your book, right? So if your b square minus 4ac, which is your D equal to b square minus 4ac, if this is greater than 0, if b square minus 4ac is greater than 0, which means your D is greater than 0, then we will say it has two real and distinct root. Which has, it means the quadratic equation has. This quadratic equation will have two real and distinct roots. When your b square minus 4ac is greater than 0. b square minus 4ac means D, when your D is greater than 0. Second is, when your D, which is equal to, or I will say this way, that way it will be easy. I'll just talk about only D. D is b square minus 4ac, discriminant. If D is greater than 0, then it has two real roots. If D is equal to 0, then it has two real and equal roots. It will have two real and equal, which means the roots will be equal. Here, when D is positive, which means greater than 0, you will have distinct roots. You will have two roots, but both will be different. If D is equal to 0, then also it will have two roots, but both the roots will be equal. And if D is less than 0, which means D is negative, then we will say it has no real roots, which means it does not have any real roots, right? So based on the value of D, and how will you calculate D? D is b square minus 4ac. And you will take this b square 4ac comes from these. Quotient of x square is a, quotient of x is b, constant term is c. From this you will take ABC, substitute here. Depending on what the value of D, we can tell what will be the nature of the roots. Whether the roots will be real and distinct, or the two roots will be real and equal, or no real roots. Fine. Now we will continue with example 16 in your textbook. So example 16, which is find the discriminant of the quadratic equation 2x square minus 4x plus 3 equal to 0. Now for this equation, we need to find the discriminant and hence find the nature of the roots. How will the nature of the roots be? Whether it will be real and distinct, or real and equal, or no real roots. So for that we should find what is ABC. What is A? Compare this with the general form of quadratic equation 2. B is minus 4. Don't take 4. Take along with the sign minus 4. C is 3, constant term. Now let's find what is D. D is what? D is equal to b square minus 4ac. So what is the value of b square? Minus 4 the whole square. B is minus 4 into A. A is 2 into C. C is 3. Now 4 square is 16. Minus, this is 24. 4 times 2 is 8 times 3 is 24, which is minus 8. D is what? Minus 8, which means D is negative. D is less than 0. D is less than 0. When D is less than 0, it has no real roots. Therefore, the quadratic equation has no, the word no is important, no real roots. That's it, we'll stop. Because they just asked what is the nature of the roots. They said find the discriminant. Discriminant is -8. It's called as discriminant. D is called as discriminant is -8 and that is less than 0. -8 is negative. When the discriminant is negative, you'll say no real roots. Fine. Now we'll go to the next one, example 17. So you can make a note of this, very important. You can pause the video and take the notes. So these three conditions is very important. You need to know, you can get some 1 mark questions based on this. Fine. So we need to know all these three. Let me erase this. We'll go to the next example, which is example 17. So example 17 says, example 17 is important. So what it says, let me read the question. A pole has to be erected at a point on the boundary of a circular park of diameter 13 meters. So there is a circular park. Fine. We want to erect a pole on the boundary. Suppose we want to erect a pole at this point P. We want to erect a pole on this circular park and the diameter is 13 meters. The diameter of the circle is 13 meters in such a way that the difference of its distance from two diametrically opposite fixed gates. So there are two gates diametrically opposite, which means suppose if this is the center of the park and there are two gates, there is a gate here and there is a gate here. Suppose there is a gate here and there is a gate here. You call this gate as A, this gate is B. So there are two gates which are diametrically opposite. Diametrically opposite means the center of the park. Diametrically opposite means AB will form the diameter. AB will be equal to the diameter of the circle and P is the point where we need to erect the pole. Right? So it says, I am reading the question again. A pole has to be erected at a point on the boundary of the circular park of diameter 13 meters. So this is 13, AB is 13. I can put here 13. This is 13 meters. In such a way that the difference of its distance from the two diametrically opposite gates, such that the distance from this pole, from these two gates, this distance and this distance, right? The difference between these two distance, the distance of the pole from this gate and the distance of the pole from this gate, the difference is 7 meters. Difference is 7 meters. Is it possible to do so? Which means, can we erect a pole in such a way that the distance of the pole from the two gates which are diametrically opposite, in such a way that the difference between that distance is 7. Difference between the distance is 7 means this distance minus this distance is 7, or this minus this is 7. One of them is 7. Right? Is it possible to do so? Means we have to get a quadratic equation. We have to represent this situation in a quadratic equation and we should find the nature of the roots. Right? And then the D should be either positive or 0. D is negative, then we will say it is not possible to erect a pole in such a way that its distance from the two fixed gates is, the difference between the distance from the two fixed gates is 7 meters. Is it possible to do so? If so, at what distance from the two gates should the pole be erected? In case if it is possible, which means if we are able to find the roots, from how much distance the pole should be erected from both these two gates? So that is the question. That is the question. So we'll say, let P be the point in which the pole has to be erected. Pole has to be erected, which means we have to keep the pole here, and we'll say let A and B be the gates which are diametrically opposite. Diametrically opposite, which means they'll form the diameter. Right? And also what is given is the difference of the distance between the point and these two gates. Now how much ever distance this pole is from this gate and this pole is from this gate, the difference of the distance, which means the difference is AP minus BP, that is given as 7 meters. The difference between the distance of the pole from these two gates is 7. We can even write BP minus AP. We don't know which order, but we'll say AP minus BP is 7 meters. This is also given. That is the meaning of when they say in such a way that the difference of its distance from the two diametrically opposite gates A and B on the boundary is 7 meters, which means how much ever distance this pole is from this gate and this pole is from this gate, that distance difference is 7. Now we should find from how much distance the pole has to be erected from gate A and gate B. So what is the value of AP? What is the value of BP? That's what we have to find. Right? Now we don't know what is AP, BP. So we'll assume. Now here I can write AP as 7 plus BP. Right? If this minus BP goes this side, it will become plus BP. Now we will take this as X. We'll take this particular value as X. So we'll say let BP equal to X. Then what is our AP? AP is 7 plus BP. So 7 plus X because BP is X. So your BP is X. If I take this as X, this becomes 7 plus X or X plus 7, doesn't matter. This becomes 7 plus X. Right? Now what we observe here is, this is one of the theorems that you would have studied in circles. See this angle, what is the measurement of this angle? This angle is how much? APB will be 90 degree. Why 90 degree? We know that any point, angle in the semicircle is 90 degree. Angle in the semicircle is 90 degree. You would have studied in your 9th standard, one of the theorems from the chapter circles in 9th standard textbook, which means if there is a semicircle, this is a semicircle. Any point you take on the semicircle and if you join the ends of the diameter, that will be 90. If you take any point, so suppose this circle is a diameter, this is a center, right? If I connect this point and this point to any point here, this will be 90. If I take a point here, if I connect this and this will also be 90. So any point that you take, even if you take a point here and if you connect the ends of these two, suppose AB, if you take a point P and if you connect the ends of these two, this will be 90. So any point, so angle in the semicircle is 90. So that is what we are going to use here. Now, so we'll say angle APB equal to 90 degree because angle in semicircle is 90 degree because AB is the diameter. AB is the diameter means this will become a semicircle. Any point you take on the semicircle and you join the ends of the diameter, that angle will be 90. So once it becomes 90, then we can apply our Pythagoras theorem. Once we know it is 90, we can apply our Pythagoras theorem. Fine. So we can use the Pythagoras theorem and we can find the value of X. Now what does Pythagoras theorem says? So this is a 90 degree. So the square of the hypotenuse is equal to sum of the squares of the other two sides. So by Pythagoras theorem, what we have? AP square plus BP square equal to AB square. This square plus this side square will be equal to the hypotenuse square. Right, now what is AP square? 7 plus X the whole square plus BP is X square equal to AB. AB is 13, so 13 square because they said the diameter is 13. Now if you simplify this, you get 7A square plus 2AB, 2 into 7 into X plus B square. If I expand this using A plus B the whole square plus this is X square equal to 13 square is 169. Now what do we get? So this is X square, so I can write this 49 plus 14X plus 2X square equal to 169. Right? I will continue here. So which means I will write 2X square first, then plus 14X, then plus 49. Then this minus 169 comes to this side, will become plus 169 will become minus 169. This plus 169 comes to the left side. From the RHS it is coming to the LHS, so it will become minus 169. So I will get 2X square plus 14X minus 120 equal to 0. Now we can again cancel throughout by 2 because 2 is common everywhere. So you'll get x square plus 7x minus 60 equal to 0. Fine. Now we need to find, if we have to solve this using any method. So they have given quadratic formula. So we can use the quadratic formula. So quadratic formula, or you can even use factorization, doesn't matter. Since it is coming under the section of nature of the roots, we also need to answer the other question saying, is it possible to do so? Right? The question says, is it possible to do so? If yes, what are the distance from the two gates should the pole be erected? Which means whether it is possible means we should check b square minus 4ac, discriminant. So let's take what is a. A is 1, b is 7, c is minus 60. Don't write 60. C is minus 60. You have to write along with the sign. Now what is D? Discriminant is b square minus 4ac. Now what is b square minus 4ac? 7 square minus 4 into 1 into c. C is minus 60. You get how much? 240. This is 49 plus 240. You get 289. That is your D. And it is greater than 0. Therefore it is possible to erect a pole. Therefore it is, D is greater than 0 means the root exists. We can find the roots, which means we can find the solution, which means it is possible to erect a pole. So it is possible. We'll say yes. I'll say yes, it is possible to erect a pole. Yes, it is possible to erect a pole. Now we should find, like, from what distance, how much distance the pole is from gate A and gate B, which means we should find the value of AP and we should find the value of BP. So if I know X, then we can find both. Right? Now let's try to solve this. Now how do we solve this? Using quadratic formula. Right? So X is equal to minus B plus or minus square root of B square minus 4AC by 2A. B square minus 4AC by 2a. That is the quadratic formula. So x is equal to minus b. B is 7. So minus 7 plus or minus square root of b square minus 4ac is 289. 289 by 2 into a. A is 1. So 2 into 1. So that gives you x is equal to minus 7 plus or minus, and square root of 289 is 17. Square root of 289 is 17 by 2 into 1 is 2. So you get x is equal to minus 7 plus 17 by 2, or you will get x is equal to minus 7 minus 17 by 2. Right? It will branch into two things. Plus 17, what happens? Minus 17, what? This will be minus 7 only. Only the, here it will become plus 17, here it will become minus 17. So your x will become minus 7 plus 17 is 10 by 2, or your x is minus 24 by 2. So which means x is equal to 5 or x is equal to minus 12. But x cannot be negative. X cannot be negative because x is the distance between the pole and the gate B. So x cannot be negative. So we say x cannot be negative. Therefore your x should be equal to only 5. So I cannot take x is equal to minus 12. So x is 5. So which means your BP is 5. So therefore we get BP is what? BP is x. X is 5. So BP is 5. And what is AP? AP is 7 plus x. And x is 5. So 7 plus 5. 7 plus 5 is 12. 12 meters, 5 meters. We have to write the units. They are very important. Right? This is 5 meters. 5 and 5 meters, comma 12 meters. So which means, so we can write the conclusion here. I am writing the conclusion. Right? So we can say, there is this, I'll write the conclusion here. So we can say the conclusion is, the final answer is, the pole has to be erected at a distance of 5 meters from gate B and 12 meters from gate A. Clear? Fine. So This is the final answer. Clear? So copy this, pause the video and please copy this notes. I am going to erase it. We'll go to the next problem. So next problem is example 18. Now what is example 18? Example 18 is the discriminant. Find the discriminant of the equation and hence find the nature of the roots. Find them if they are real. If they are real. So which means let's write the equation 3x square minus 2x plus 1 by 3 equal to 0. This is a given equation. Now we need to find the first part is we have to find the nature of the roots and then we should find them if they are real. If they are real means your d should not be negative. If the d is negative, then they are not real. If the d is positive or d is equal to 0, then we can say that the roots are real and we can find them. Now we have to solve this. So we need to convert this in the form of our general form of quadratic equation, which is ax square plus bx plus c equal to 0. It is in this form only. It is in this form only, but we can try to avoid the denominator. We can try to avoid the denominator by multiplying every term by 3. So if you multiply every term by 3, this will become 3 into 3x square plus 3 into minus 2x minus 3 into 2x plus 3 into 1 by 3 equal to 3 into 0. I am multiplying each term by 3. Then this will become 9x square. This will become minus 6x. This 3 will go. I will get plus 1 equal to 3 into 0, 0. Right? Now we don't have a fraction. You can even keep as it is and say a is 3, b is minus 2 and c is 1 by 3 and do it. That's how they have done it in the book. It's been generally better to avoid the fraction. Now what is a here? Now a is 9. Your b is 6. No, it is minus 6. And c is 1. This one. Now let's find what is b square minus 4ac, because that is what. So d is b square minus 4ac. So this is what is going to tell you the nature of the roots. The b square is minus 6 the whole square. Minus 4 into a is 9 into c is 1. You will get 36 minus 36, which is 0. When d equal to 0. When d equal to 0, the roots are real, but they are equal. So we will say it has real and equal roots. Now we have to find them. We said that the roots are real. So we need to find the roots. So how do we find the roots? We will go to the quadratic formula. What is the quadratic formula? X is equal to minus b plus or minus square root of b square minus 4ac by 2a. Fine. So x is equal to minus b and b is how much? Minus 6. So minus of minus 6 plus or minus square root of b square minus 4ac is 0. So d became 0. So 0 by 2 into a. 2 into a is 9. So you'll get x is equal to minus of minus 6 is plus 6 plus or minus 2 square root of 0 is 0 by 2 times is 18. Right? Now again it will branch into two parts. Right? So it will branch into two parts, which is x is equal to 6 plus 0 by 18. 6 plus 0 by 18 or 6 minus 0 by 18 or 6 minus 0 by 18. 6 plus 0 by 18 or 6 minus 0 by 18. So which means x is equal to 6 by 18 or 6 minus 0 is also 6 by 18, which means x is equal to 1 by 3 or 1 by 3, which means the roots are 1 by 3 and 1 by 3. 1 by 3 and 1. Here I should put x equal to x equal to x equal to. The roots are 1 by 3 and 1 by 3. Here we already said the roots will be equal because it is 0. B square minus 4ac is 0. So the roots are 1 by 3 and 1 by 3. Fine. Now let's go to exercise 4.4. We'll go to exercise 4.4. So exercise 4.4 in your textbook, page number 91 in your textbook, page number 91 in your textbook, exercise 4.4. So we'll do the first problem. In first problem, first subdivision, what it says is, first problem is, first subdivision is 2x square minus 3x plus 5 equal to 0. Now we should say find the nature of the roots of the following quadratic equation. If the roots, real roots exist, find them. Real root exists, find them. So the first thing is, we should find out what is ABC. A is 2, B is minus 3 and C is 5. Comparing with this, ax square plus bx plus c. Compare, A is 2, B is minus 3, or write along with the sign. Don't put just 3. B is minus 3, C is 5. Now what is b square? D. Discriminant is b square minus 4ac. What is the value of b square minus 4ac? B square is minus 3 the whole square minus 4 into A is 2 into C is 5. You get 9 minus 8 times 40. 40. 8 times 5 is 40. So you get D is equal to minus 31. D is equal to minus 31. So which means your D is less than 0. Which means when D is less than 0, we'll say it has no real roots. It does not have any real roots. No real roots. Clear? So which means we need not go further and find them. Whenever the value of D is negative, we should stop the problem and say it has no real roots, or real roots don't exist, whatever. Right? Now we'll go to the second problem. In the first problem, second subdivision. So problem number 1, second subdivision. Right? So what it is 3x square minus 4 root 3x. 4 root 3x plus 4 equal to 0. Plus 4 equal to 0. 3x square minus 4 root 3x plus 4 equal to 0. Now we need to find whether the real root exists. If it exists, we need to find them. So again we should find what is A. A is what? 3, coefficient of x square. B is 4 root 3. No, minus 4 root 3. Minus 4 root 3. And C is 4. This one. Now let's find what is D. Discriminant is b square minus 4ac. And B is what? Minus 4 root 3. So minus 4 root 3 the whole square. That is b square. Minus 4 into A is 3. Into C is 4. Now 4 root 3 the whole square is 16. 16 3s are 48. This is minus 48. 12 4s are 48. So it becomes 0. When D equal to 0 means it has real and it has, we can say it has 2. It has 2 real and equal roots. Which means real root exists. So we can find them. We can proceed and try to find the value of that. Now what is that? So that will be x equal to minus b plus or minus square root of b square minus 4ac by 2a. That is the formula for finding the roots. So minus b is minus 4 root 3. So minus 4 root 3. So this minus is this minus formula, and b itself is having a minus. Double minus will come. You have to be careful. Plus or minus square root of b square minus 4ac is what? 0. 0 by 2 into a. A is 3. 2 into 3. So this will become 4 root 3 by 2 3s are 6 plus or minus square root of 0 is 0. That is your x. Now x will branch into 2. So x will become 4 root 3 plus 0 by 6, or x is equal to 4 root 3 minus 0 by 6. Fine. So which means your x becomes 4 and 6. If you get cancelled, you get 4 root 3 by 6, or here also x is equal to 4 root 3 by 6. Fine. Now what happens? So x is equal to, now 4 and 6 can be cancelled. You get 2 by 3. So you'll get 2 root 3 by 3, or x is equal to 2 root 3 by 3. When we need not cancel this root 3 and say this as 2 by root 3, we can stop here. In the book they may cancel and they might have given it as 2 by root 3. They might have given it as 2 by root 3, but let's not do that, because it's better to not to have an irrational number in the denominator. So we'll stop it here. So the roots are 2 root 3 by 3 and 2 root 3 by 3. So we have solved and we have found the roots, and the roots are real and they are equal. See, they may also write, you can also write this 2 root 3 by 3 as, you can cancel this root 3 and 3 and you can say root 3, you can say 2 by root 3, you can say like that, still it is okay. But we try to avoid having an irrational number in the denominator, so we can write it as 2 by 3 root 3, 2 by 3 root 3. Fine. If you want to write as 2 by root 3, 2 by root 3 also, it's fine. The value of this is 2 by root 3. Value of this is also 2 by root 3. Fine. Now let's go to the next one. The third one, which is 2x square minus 6x plus 3. So first problem, third subdivision. 2x square minus 6x plus 3 equal to 0. Fine. 2x square minus 6x plus 3 equal to 0. Now we need to solve and find. First we should check whether the root exists, real root exists. If the real root exists, we should solve. So again, a equal to what? 2. B equal to minus 6. C equal to 3. Now what is D? D is b square minus 4ac. Let's find the discriminant value. Minus 6 the whole square into 4 into a is 2 into c is 3. So this is 36. Sorry, this is minus. Minus 4 times 2 is 8. 8 3s are 24. So minus 24, we get 12. D is 12, which is greater than 0. When D is greater than 0, then we can say it has. So we can say it has 2 real and distinct roots. It has 2 real and distinct root. So we can solve and find the value of roots. Find the value of the zeros or the solution. X is equal to minus b plus or minus square root of b square minus 4ac by 2a. So x is equal to minus b. B is how much? Minus 6. So you will get minus of minus 6 plus or minus square root of b square minus 4ac is 12. Value of b square minus 4ac is 12. So 12 by 2a. 2 into a is 2. So your x will become minus of minus 6 is plus 6 plus or minus 12 can be written as 2 root 3. 12 can be written as 2 root 3 by 2 times 2 is 4. Fine. So now it will branch out into 2 parts. So your x is 6 plus 2 root 3 by 4. 6 plus 2 root 3 by 4 or 6 minus. Or 6 minus. Or we can do one more step. Here we can do one more step. We can take 2 common here. So x is equal to, if I take 2 common, I'll get 3 plus or minus root 3 by 4. If I take 2 common from the numerator, then this 2 and this 4 will get cancelled. I'll get 2. So you get x is equal to 3 plus or minus root 3 by 2. So which means it will branch into 2 cases. Right? X is equal to 3 plus root 3 by 2 or x is equal to 3 minus root 3 by 2. X is equal to 3 plus root 3 or 3 minus root 3 by 2. Clear? So therefore we will say the roots are 3 plus root 3 by 2 and 3 minus root 3 by 2. Clear? So these are the 2 roots for this particular problem. Fine. So we will stop the video here. I'll end the session here. You can watch my next video for the continuation of this exercise. Thank you for watching. See you in the next video. Thank you.